Swayam Prabha. Digital India. Educated India.
In this lectures, I am going to talk about artificial intelligence. In contemporary philosophy of mind, artificial intelligence plays a vital role in explaining mind in different ways, and mind plays important aspects in artificial intelligence, because in any definition on artificial intelligence, if you see on any book, and you find that artificial intelligence is, you find that the concept of mind is there, and the concept of intelligence is there, and all the mental concept is there. Ordinarily, we can say that artificial intelligence is a machine making do things, and it requires intelligence if done by human beings. And the object of research in artificial intelligence is to discover not only how to program a computer to perform the remarkable function that make of human intelligence, but also it leads increasing the use of computers, also enhanced understanding of human cognitive processes, which constitutes what we mean by intelligence and the mechanism that are required to produce it. What is needed here is one of the deeper understanding of human intelligence and the human mind. Here we will focus on the various definitions of artificial intelligence and organize it into many categories. The basic tenets of this thesis, especially artificial intelligence, is that the brain is just a digital computer, that the mind is a software program, and especially in the mid of 19th century, the hypothesis a machine can think and becomes very popular after Alan Turing's article on computing machinery and intelligence. This thesis claims that a machine can think and machine can act, machine can do rational activities and many other things which we human beings are doing. Therefore, mind can be explainable in terms of machines, or machine can be explainable in terms of mind, and there is no distinction between mind and machine. The same way there is no distinction between mind and body. That is why it is one of the main thesis, one important part of the contemporary issues in philosophy of mind. For them, the brain is just a digital computer, and that the mind is a software program. There is a slogan that mind is the software and the brain is the hardware in which mind functions. Now, let us see what is this artificial intelligence. It is very difficult to give any kind of precise definitions. Let us see what is artificial intelligence. First, let us see these definitions on artificial intelligence, which is defined by John Hogland. Let us see this PPT. The exciting new effort to make computers think and machines with minds in the full and literal sense. Secondly, if we see, according to Bellman, it is the automation of activities that we associate with human thinking activities such as decision making, problem solving, learning, and etc., and which is the Bellman's definitions. And from this we can conclude that system that thinks like humans. How they are concluding? Because from these two definitions, if you see differently, especially the definition of Hogland and Bellman, both of them are explaining that artificial intelligence is concerned with the thought processes and reasoning. They have explained that the mind as a machine that is completely associated with human thinking, and therefore, that is to say that computers do things, therefore, system that thinks like humans. And secondly, if we see some of the definitions given by some other scientists like Charnack and McDermott, for them artificial intelligence is the study of mental faculties through the use of computational model, and according to Winston, the study of the computations that make it possible to perceive, reason and act. This is one of the important factors in the Winston's thesis on mind. If you go back to the Hogland way of definition, because he has explained the full and literal sense, the machine is full and literal sense like the mind, and here even in the full and literal sense, the way even if we understand the general thinking, the general story or general things about the world and intentional factors about the world, the same way a computer system can understand in the same way. Here McDermott, Charnack and Winston are concerned, but here McDermott and Winston are concerned with an ideal intelligence, that intelligence which is equivalent with the human intelligence, and therefore, there is no distinction between the human intelligence and the artificial intelligence, and both are going together. And they explain the mental faculties through the use of computational models, and therefore, there is no distinction between mind and machines. That is also rationality capacity also is there in the case of Winston's and McDermott's thesis, because there mental faculties is there, it can perceive, it can have reasoning capacity, it can act, therefore, it can do any kind of rational activities, and these rational activities are there. Let us see some other explanations on artificial intelligence, and according to Kurzweil, the art of creating machines that perform functions that require intelligence when performed by people. And here Kurzweil is explaining one of the weak sense, creating machines and that are also intelligence, and machines have also intelligence whenever we human will perform and we require intelligence. And Rich and Knight says that AI is the study of how to make computers think, at which at the moment people are better. And both Kurzweil and Rich and Knight are explaining the weak sense of artificial intelligence, but even if this intelligence belongs to the human mind, and although this intelligence human performance is there, human function is there, but at the same time all these functions are basically belongs to the human mind and human things. Even if whatever the mechanical activities is there, those mechanical activities can be attributed to the humans, and humans are better than the machines. It is one kind of weak way of explaining the artificial intelligence, but in the case of, if you see the Hogland thesis and the reverse way, it is one kind of a strong thesis. Hogland, Winston's, all of them have raised that it is a strong way of that mind is machines. There is no distinction between mind and machine. Mind can be reducible to the machines, and this reductionist explanation is the right explanation on this. Whatever way the artificial intelligence is explaining about mind, and that is about the mind. Let us see some of other definition on artificial intelligence. Here, according to Kafef, that a field of study that seeks to explain and emulate intelligent behavior in terms of computational process. And secondly, this Storfield and Loger says that the branch of computer science that is concerned with the automation of intelligence behavior, therefore, system that act rationally. Therefore, intelligence behavior is there, therefore, rational activities are there. And here both Loger and Stofferfield are concerned with the behavior aspects of systems. If you summarize all the definitions of artificial intelligence, can be organized into 4 categories. They are follows: the system that think like humans, the system that act like humans, the system that think rationally, and the systems act rationally. And these points can be elaborated in different ways, and now you have to look at each aspects in differently, and because which is very important to see, how these points are related to different philosophical as well as scientific aspects of mind. Let us see this acting humanly. First we have to see Turing machine approach, and thinking humanly, the cognitive modeling approach, and the thinking rationally, the laws of thought approach, and acting rationally, the rational agent approach. All these four approaches are explaining about the mind, and they are giving that explanations which shows that there is no distinction between mind and machines. Let us see this Turing machine's approach on acting humanly. The Turing thesis test is named after Alan Turing, who was a British philosopher as well as mathematician, logician, was designed to provide a satisfactory operationally definition of intelligence. Turing defined that intelligence behavior as the ability to achieve human level performance in all cognitive tasks to fool an interrogator. In his article on computing machinery and intelligence, Turing says the new form of the problem can be described in terms of a game which we call the imitation game. It is a game played by a man and a woman and an interrogator who may be of either sex. The interrogator stays in a room apart from the other two rooms. The object of the game for the interrogator is to determine which of the other two is the man and which is the woman, and he or she knows them by labels x and y. At the end of the game, he or she says that either x is A or y is B, or x is B or y is A. The interrogator is allowed to put questions to A and B. Thus, she will ask the questions, will x please tell me the length of his or her hair. Now, suppose x is actually A, then A must answer to the questions, and the main aim of this game is to fool the interrogator. But if the communication is between the interrogator and the two other people, either men or women, those who are sitting separately, the best way of communication is a teleprinter. That teleprinter is the perfect medium of communication to recognize the intelligence. Alternative, an intermediately can repeat the equations and answers. The object of a game for the second player, that is B, is to help the interrogator. The best strategy for her is probably to give a truthful answer, and she can add to her answer such thing as I am the woman, do not listen to him, but it is of no avail, as the man can make similar remark. Now, we can ask questions, what will happen when a machine takes the part of A in this game. Now, the question is, will the interrogator decide wrongly as often when the game is played like this as he does when the game is played between the man and woman? Turing's answer to these questions are more or less summed up in this way, that even if he believes that there is a possibility that we can program the computer which will storage capacity of about the way even if human being is storing the memory or everything else, to make them play our imitation game, as well as an average interrogator will not have more than any 70% of chance of making the right identification after 5 minutes of questions. What Turing had predicted at that time, now in fact is a fact that the machine or the computer can imitate human behavior, and it should be pointed out that the Turing's beliefs about the capabilities and the capacities of machines are not limited to such activities as playing the imitation game as successfully as human beings. Roughly speaking, the test Turing proposed is that the computer should be interrogated in the place of human beings. Turing test deliberately avoided physical interaction between the interrogator and the computer, because physical limitation of a person is unnecessary for intelligence. However, the so-called Turing test includes a video signal so that the interrogator can test the subject's personal perceptual attitudes. In order to pass through total Turing test, the computer will need a computer vision to perceive objects and robotics to move them. Again, the issue of acting like a human comes up primarily when artificial intelligence programs have to interact with people, as when experts system explain how it came to its diagnosis, or a natural language processing system has a dialogue with the users. These programs must have, according to certain normal covertness of human interaction in order to make them understood. The Turing test shows that the machine can interact with human beings that the way human beings interact amongst themselves. That is to say that machines can behave the way the human beings do. And here I would like to give some more examples like that. The way presently we are chatting, even if in the case of chatting it is very difficult to say. Suppose I am writing something online, that chatting somebody else, even in the opposite side, that may not be a human being, that may be a program, and it is very difficult to recognize either he or she is present in the opposite side, and what way he or she is thinking, she is doing activities. In the same way, the Turing, whatever Turing was proposing, now the chatting machine, the online chatting is the same way of doing one kind of activities. Therefore, Turing thesis is not a false, but some sense Turing thesis is trying to simulate or duplicate the human mind, but through mechanical way showing in the explanation of the mind that. And even if any kind of computer we can say is a Turing machine, even if a computer we can say in a robotic machine, or we can say also physical symbol system also, because there is a physical is there and all those things are there. For example, even if Turing state, it can be called a finite state automata. Many people have claimed that, many scientists claim that it is a finite state automata. It is functioning in a finite state automata, it is not a infinite state automata. All these things will be very clearer if you see some of the points like the thinking humanly, the cognitive modeling approach, which is one of the important model in developing the cognitive science or cognitive psychology. They are explaining about the human mind or about the computational model of mind. And let us see thinking humanly, the human cognitive approach. As we know, the interdisciplinary field of cognitive science belongs together computer models from artificial intelligence and experimental techniques from cognitive psychology to try to construct precise and testable theory of the working of human mind. And if you are going to say that a given program thinks like a human beings, we must have some way of determining how human beings thinks. For that, we need to get inside the actual working of the human mind. Stuart Russell and Peter Norvig says that there are two ways to do this: through introspection, trying to catch our own thoughts as they go by, or through psychological experimentations. Once we have a sufficiently precise theory of the mind, then it becomes possible to express the theory as a computer program. If the program's input, output and timing behavior matches human behavior, that is to say that the evidence that some of the programs mechanism may also be operating in humans. Now, it is almost taken for granted by many psychologists that a cognitive theory should be like a computer program. But as we know that cognitive science is the science of mind, the cognitive science is the science of mind. Therefore, cognitive scientists seeks to understand perceiving, thinking, remembering, understanding, language learning and other mental phenomena. Their research is remarkably diverse, ranging from observations children's mental operation through programming computers to do complex problem solving to analyzing the nature of meaning. In order to appreciate the work in artificial intelligence, which is necessary part of the cognitive science, it is necessary to have some familiar with theories of human intelligence. The cognitive scientist introduced the notion of machine intelligence and emphasizes the relationship between human and machine intelligence. The aim of artificial intelligence is to develop and to test computer program that exhibit characteristic of human intelligence, and the most fundamental contributions of symbolic computational modeling has been the physical symbol systems. According to Newell and Simon, a physical symbol system has the necessary and sufficient means for general intelligent actions. And here, what is physical symbol system? As I told you from the beginning, even if we can call a machine as a machine or a Turing machine or artificial intelligence or a finite state automata or a physical symbol system. According to Simon and Newell, a physical symbol system has the necessary and sufficient means for general intelligent actions. By necessary, here we mean that any system that exhibits general intelligence will prove upon analysis to be a physical symbol system. And secondly, by sufficient we mean that any physical symbol system of sufficient size can be organized to exhibit general intelligent actions. And lastly, by general intelligent action we wish to indicate the same scope of intelligence as we see in the human actions, that states that any kind of actions it will react to the appropriate demand of the environment that occur within some systems. And this thesis claims that according to Simon and Newell, that there is no distinction between mind and machines, because it has sufficient size, it can produce, reproduce and establish, reinterpret, and this intelligence is necessary equivalence to with human intelligence. Therefore, there is no distinction between human intelligence and physical symbol system. Again, they claim that the ability of computer simulations to model such process is interpreted as a proof of the broader claim that a symbol system is at the center of human intelligence. In this hypothesis, it shows that intelligence is an essential aspect of machines. If the machines have the capacity of intelligence, intelligence is the essence of human cognition. Therefore, machines have cognitive capacity like the human beings. In the cognitive modeling approach, thus human beings and machines shows the property of being intelligent. Therefore, from this cognitive modeling approach, we see that machines are intelligent, there is no distinction between human being and machines. And thirdly, we have to see now thinking rationally, the laws of thought approach. The laws of thought approach plays important role in, even if in the case of Aristotle and philosophy, because rationality is the key concept in Aristotelian philosophy. If you see, Aristotle has explained that without rationality it is very difficult to do any kind of things. Even if the AI scientists and cognitive scientists, they have tried to simulate and to implicate in the rational capacities in the machines, and they have tried to implement these rational capacities in the machines. Right thinking is the inferential character of every reasoning processes. Aristotle in his famous syllogism provided the pattern of argument structures that always give a correct conclusion from given correct premises. In the Aristotle syllogism, the laws of thought plays a vital role, because these give law of the right explanation of syllogistic inferences. There are three laws of thought recognized by the logicians, and these have traditionally been called the laws of identity, the laws of contradictions, and the laws of excluded middle. And these laws of thoughts are appropriate to different contexts, and the formulations appropriate as follows. The laws of identity assert that if any statement is true, then it is true. This law asserts that every statement of the form P and P is true, and that every such statement is tautology all the time, and it is true. It is a one kind of universal truth, and there is no distinction between this kind of things. And the laws of contradiction assert that no statement can be both true and false. This laws assert that every statement of the form P is false, that is, every such statement is self contradictory and its negation is logically true. And thirdly, the laws of excluded middle assert that any statement is either true or false. These laws assert that every statement of the form P and P is true, that is, every such statement is tautology. In this laws of thought approach to artificial intelligence, the whole emphasis is on the correct syllogistic inferences. For example, we can say that concretely Socrates is a man, all men are mortal, therefore, Socrates is a mortal. In these inferences, the conclusion is based on the premises according to the rules of inferences. The above syllogistic inferences is based on to formulate artificial intelligence program. In all reasoning of this type, the emphasis is on the logical inference of a conclusion from the premises. In the artificial intelligence program, this type of logical inferences is of much use, since this programs provides a variety of logical reasoning in an inference, a set of variable, a set of constant terms and a set of function, the set of connectives, if and or not quantifier exist for all the important symbols to build an AI program. All these constant and variables are the arbitrary representation of the world. With the help of all these so called logistic tradition within the artificial intelligence, hope to build on such a program to create intelligent systems. If this is possible, then the rational thought is possible. In order to be rational, all these logical reasoning and logical capacities are necessary. Without logical capacity, it is very difficult to have a rational capacity or rational thinking or rational activities. And how artificial intelligence is defining mind, at the same time defining artificial intelligence. Whenever the AI scientists are defining artificial intelligence, they are using the term mind and then concluding that there is no distinction between mind and machines, and machines or artificial intelligence can be defined in terms of mind with machines, and therefore, there is no distinction between mind and machines. And as you know, the rationality is one of the important factors of human mind, and this rationality we can find in the computational system according to AI scientists. And if you see this PPT acting rationally, they have said that the rational agent approach, agent is equal to architecture plus program, and here they have been and they are arguing that this rational capacity or rationality we can find or re-implement or simulate in a machines, and if simulation is possible, then the same way the human mind is working. Therefore, and this rationality not only existing in the human mind, but also existing in the machines. Acting rational, the rational agent approach. Actually, it is agent refers to a mechanical agent, that is so a computer or a robot. And acting rationally means acting so as to achieve one's goal given one believes. An agent or a mechanical agent is something that perceives and acts also, and it can decide what to do, what not to do, because the rational capacity is there. The correct in any kind of rational activities, you will find that being a rational agent, we have to derive from the correct inferences, because one way to act rationally is to reason logically to a conclusion given action that will achieve one's goals and then to act on that conclusions. And according to AI scientists, that rational agent therefore have two advantages. Firstly, they say that it is more general than the laws of thought approach, because correct inference is only a useful mechanism for achieving rationality and not a necessary one. Secondly, it is a more amenable to the scientific development than approaches based on human behavior or human thought, because the standard of rationality is clearly defined and completely general, and therefore, it arises from the agent is something that perceives and it also act according to the environment. But here we have to point out that the job of artificial intelligence is to design the agent program, that is a function that implements the agent mapping from percepts to actions. And we can assume from this program, and this program will run on some sort of computing device. A human agent has eyes, ears and other organs for sensors, hands, legs, mouth and other body parts for effectors. Therefore, the relationship among agent and architectures and programs can be summed as of like this: acting rationality, the rational agent approach, agent is equal to architecture plus program. Let us see this PPT. The agent is autonomous to the extent that its behavior is derived by its own experience. A truly autonomous agent should be able to operate successfully in a wide variety of environments, given sufficient time and scope. But before we design an agent, we must have a partly good idea of the possible percepts and actions. The agent's goal is supposed to achieve and what sort of environment it will operate in it. Again, as we have mentioned that an agent is something to perceive and acts. In this approach, artificial intelligence is viewed as the study and the construction of rational agent. One of the important factors is that correct inference is not the whole of rationality. There are also way of acting rationally, and that cannot be reasonably be said to involve inferences. For example, pulling one's hand of a stone is a reflex action that is a more successful than slower actions taken after careful deliberations. Therefore, this shows that computational systems act can rationally. Therefore, all these definitions on AI whatever we have defined is a scientific definitions, but also a philosophical implication for explaining the concept of mind. And here we have explained about the system that think like humans, the system that act like humans, system that think rationally and system that act rationally. And all these things we have explained in approach to the Turing approach, then cognitive modeling approach, then laws of thought approach, then rational agent approach. Therefore, all these approaches are one of the AI model of mind, and they are explaining in the scientific way. In the next lectures, we have to see the field of AI and whether AI is art or science and what artificial intelligence or a computer can do. All these things plays vital role, because these are the necessary to explain in the introductory classes of artificial intelligence. Although I am not going deep into the scientific aspects of AI, and I will be dealing with the general introduction of artificial intelligence and then some of the philosophical arguments or limitations to artificial intelligence. Thank you.